Good afternoon, and thank you so much for the invitation to come and speak here today. I've had a great day getting to know a bunch of people. So today I'm going to be talking about our research on emotional brain development in humans. And the question that we address in our lab is not a new question at all. It's actually a very fundamental question in psychology, which is how do we explain this enduring link between early experiences and our later functioning, particularly in the realm of emotional behaviors. And we can appreciate right away that this is quite a link, because in humans it lasts not for a few years, but perhaps for an entire lifetime. So the approach that we've taken in our lab is to study brain development as a potential mediator for explaining this enduring link. And for today's talk, I'll be focusing on the connections between the amygdala and the medial prefrontal cortex. Now, the amygdala is a deep, early developing structure in the brain that helps us with emotional learning and emotional attention, paying attention to what's safe and dangerous in the environment. And in adulthood, the amygdala has strong two-way connections with the medial prefrontal cortex. And the medial prefrontal cortex is a big chunk of brain real estate that coordinates and collects information from many regions of the brain and from the rest of the body, and coordinates it and synthesizes it largely in service for regulating some of the over-arousal of the amygdala. And as I'm going to be describing today, this two-way street, or these connections, take a very long time to develop in the human. Our approach in the lab is to study this system as it's developing, not just looking at the endpoint in adulthood, because sometimes you get different answers when you study things as they're cooking. Now, if we look at a number of mental illnesses associated with emotion dysregulation, broadly speaking, they tend to show their peak age of emergence at the beginning of adolescence. So our approach is to look at the antecedent period to adolescence to understand what's happening prior to the emergence of all of these individual differences in emotional behavior to better understand the influence of early experiences. So when we look at human amygdala development, the basic neuroanatomical architecture is present by birth. And within the first year of postnatal life, there is a dramatic increase in the volume of the amygdala, which is followed by a much smaller increase in years thereafter. So there is continued change in amygdala volume well past puberty, but all of those changes are really dwarfed by what's happening in the first year of life. So the structure of the amygdala, at least volumetrically, is well established soon after birth. Now, it's easy for us to focus on emotional behaviors of infants or toddlers, or the emotional behaviors of adolescents, and often we don't think too much about what's happening during childhood. So Freud, unfortunately, labeled this period the latent period, which connotes perhaps that nothing really interesting is happening. It happens to be a time of life that our lab is particularly interested in, for reasons that I hope I can convince you of, that much is going on, even though it may be less obvious. So to ask some of our questions about amygdala function, we have taken the approach, like here in this study, to bring in a wide range of participants. This is a cross-sectional study here. Individuals were between the ages of 4 and 22 years old. And we just present them with static, two-dimensional images of people making these fearful faces. Now, there's a lot of limitations to using static, two-dimensional fear faces, but a great advantage of this is that if one is interested in activating fear-related circuitry in very young children, a fear face is a pretty innocuous stimulus to use, right? We're not using shock, we're not showing them really horrible images, but fear faces of other people are really good activators of the circuitry. So in all of these participants, they view these fear faces, and then we perform standard processing on everyone's brains, and then we smush the brains together analytically, and we search the entire brain for regions that are changing in their activation as a function of age. And the amygdala was one of two regions that emerge as showing significant age-related changes. So blue here indicates a negative correlation with age. I'm pulling out that response here on this figure so you can see it better. Age is on the x-axis and amygdala reactivity is on the y-axis. And what you can readily see is that the younger participants were, the stronger the amygdala response was. Now, this strong response early in life actually makes a lot of sense because when you're young and you're new to this planet, you have a lot of learning to do about the relative safety and danger of the environment. So you want the amygdala already activated at a young age. But we can use these same data to look at connections between the amygdala and other regions of the brain like the prefrontal cortex. And the way that we assess this connectivity is to do something called a functional connectivity analysis. Now, a functional connectivity analysis, if you're not familiar with it, is pretty simple. We extract the time course of activity from one region, like the amygdala, and plot it out over time. And then we extract the activity of another brain region, like the prefrontal cortex, and plot it over time. Now, the more correlated these two lines are, gives us an index of how functionally coupled or connected these two brain regions are, as if they must be in some type of conversation with each other. Now, the two time courses can be positively correlated, as I'm showing you here, or in the case of amygdala and prefrontal cortex, what we often see is that they're negatively correlated with each other, which means when one region increases its activity, the other region decreases its activity, which often is interpreted as a regulatory type relationship. And it's that regulatory type relationship, that negative correlation, that's often observed in healthy adults when engaged in any type of emotion regulation activity. So we can perform this analysis on all of our participants from 4 to 22, and we observe that the medial prefrontal cortex changes in its connectivity strength with the amygdala as a function of age in the following way. So these are adult data plotted here. This is now not activation, this is that connectivity measure. In adults, in young adults, we see that negative correlation pattern that I just described to you, suggesting when one region, like the prefrontal cortex, increases its activity, the other region, like the amygdala, decreases its activity, suggestive of a regulatory relationship. In younger and older adolescents, we still see evidence of that negative correlation, although you can appreciate its magnitude is diminished, which is consistent with what we know about the slow development of emotion regulation across adolescence. But what we were most interested in is what we observed during childhood, where we didn't see that negative correlation. We saw a positive correlation between amygdala and medial prefrontal cortex, which at the very least gives us a hint that the nature of the conversation between amygdala and prefrontal cortex is different in childhood than it is at points thereafter. So to show you in cartoon format what I just described, in the adult state, in response to things like fear faces, we see this inverse relationship between amygdala and prefrontal cortex, consistent with a regulatory pattern. But in childhood, we see that these two regions are moving together, not in a regulatory fashion. Now, the nature of that conversation between amygdala and prefrontal cortex is correlated with developmentally normative behavior changes. So separation anxiety is a normative behavior that children show at young ages, and it decreases as we get older. So if we look at normative separation anxiety, we see that children who show the positive correlation, that is the more childlike pattern of connectivity between amygdala and prefrontal cortex, have higher separation anxiety than the children who display the more mature, in quotes, pattern of the negative correlation. So this is suggesting that the nature of the conversation between amygdala and prefrontal cortex is related to the child's willingness to venture off from the parent. So taken together, these two data, if this is X on the age on the x-axis, these two data show us that at least during childhood, we're getting a very strong early amygdala response. but that's happening in the absence of these adult-like connections with medial prefrontal cortex, which we don't see emerging until the beginning of adolescence. So that makes childhood for us a very interesting time to consider when thinking about when might sensitive periods of development be happening in emotion regulation neurobiology. Moreover, we will go on to posit, as I'll show you, that this strong activity of the amygdala is actually the biological prerequisite for the instantiation of these regulatory inputs from prefrontal cortex. So the reactivity itself at time 1 might be responsible for the ultimate instantiation of the regulatory circuits that we see emerging later on in maturity. So a working hypothesis of what we're seeing here is the following, that given that brain development occurs in a hierarchical fashion where lower brain regions tend to develop earlier than higher and front regions, given that relationship, it might be that early in life the amygdala is driving much of the conversation to the prefrontal cortex. So I like to think of the amygdala as the older sister that got there first and can instruct the prefrontal cortex about what the world is like that she's experienced so far. And it's that conversation that over time that helps instantiate these top-down regulatory connections from the prefrontal cortex. And animal studies that can say something more than correlational fMRI studies have suggested this explanation has merit, because tracing studies show that amygdala sprouts to prefrontal cortex develop earlier than the return prefrontal cortex connections to the amygdala. So that pattern of development reminds us of a 200-year-old quote by William Wordsworth, that the child is the father of the man. So in other words, if we simply have an adult vantage point of this neurobiology, it's easy for us to often think about or conceptualize the prefrontal cortex as controlling the amygdala. But if we take a developmental vantage point, then we can appreciate that the amygdala is actually driving much of the fate of this system. And so developmentally, the amygdala may be thought of as a kind of tutor for the cortex. So to address this question of whether the nature of communication between amygdala and prefrontal cortex has enduring consequences or predictive value for the future functioning of this system, we not only had those stimulus-elicited connectivity maps that I just showed you, but we also collected something called resting state connectivity. Now, if you're unfamiliar with resting state connectivity, this is a connectivity measure we get when somebody is not engaged in any task. And so it provides us with an index of essentially a functional architecture of the brain. And we collected both of those modalities in all of our participants, and then brought everybody back 2 years later and collected the same 2 modalities. And what we observed was that the stimulus-elicited connectivity at time 1 was the best predictor of this future resting state connectivity. Another way to say that is the way that the amygdala and prefrontal cortex talk to each other in response to environmental stimuli at time 1 is the best predictor of how this functional architecture observed later on in development. It was a better predictor than the previous resting state. So this is consistent with the notion that the system is getting molded over the course of development by environmental activations. Moreover, the strength of that prediction from time 1 to time 2 was stronger in young participants in childhood and attenuated at points thereafter. So the idea is that the stimulus-elicited connectivity was really good at predicting what children's future resting state was going to look like, but as we get older, the relationship starts to become bidirectional, no longer a one-way street. So that finding is consonant with the notion that during childhood we have a more plastic, flexible system that's responsive to environmental stimuli and that settles into a more stable pattern of connectivity observed in adulthood. So these findings then prompted us to formally ask, is this middle childhood period a sensitive period for development of the connections between medial prefrontal cortex and the amygdala. This is a program of research that's highly inspired by several rodent studies that have shown that stimuli that are learned early in life can be used later on in adulthood, often to exhibit anxiolytic or anxiety-reducing properties. But you can appreciate with me that being able to ask the question about whether a stimulus experienced in childhood has any special effect in adulthood presents a lot of challenges in terms of experimental design. Because either you can bring in a child, expose them to something, and then let them grow up into adulthood and test them. That's going to be challenging. Or you can bring in an adult and test the efficacy of some stimulus from their childhood, but how certain are you that they were exposed to that stimulus during that specific window? So we were fortunate enough to collaborate with Takao Hench, who's a physiologist at Harvard and an expert in sensitive period identification. And in mice, he showed that music that the mice were exposed to during their childhood equivalent was really effective in reducing anxiety later on in adulthood. And that was exciting to us because music maybe gave us an avenue for asking this question in humans. He used Beethoven's Symphony No. 1. So if you expose the mouse to Beethoven's Symphony No. 1 in adulthood, that's what they prefer, and it reduces their anxiety and it activates prefrontal cortex. And jazz doesn't, and vice versa. So we could use music, maybe not Beethoven's Symphony No. 1, but we could use pop music and use data from the Billboard charts to know approximately how old somebody must have been when they were bathing their brain in this stimulus. So it allows us to target with a little more certainty the age range of interest, which is childhood, and contrast that to another age range like adolescence. So let's say that we brought in a young adult in the year 2012 when we were designing this study. And we want a stimulus from that adult's childhood. So a stimulus from when they were about 7 years old. So if we do the math, then we need a stimulus from 1997. So we searched the archives and we found such a stimulus. And we could use music from the Backstreet Boys, for example. Now, of course, this study was a fun study to do. It gave us a little more confidence that childhood, something special is happening during childhood in terms of this brain circuitry. But we're not interested in what the Backstreet Boys do to your brain. We're really interested in a more species-expected stimulus that's coincident with this developmental period, which is the caregiver. So lots of mammals spend time with their caregiver, and the human is one of them. In the human, I just want to point out quickly, the primary caregiver certainly doesn't have to be the mother. It can be the father, it can be the grandparents, it can be an adoptive parent, because this is a learned relationship. And that's true of many species, that this is a learned relationship. However, what is perhaps unique about the human is how long we spend with our parents. So in most species, this period of dependency lasts on the order of months, and in humans, it's on the order of years, which is an interesting design, evolutionarily speaking, for Mother Nature to come up with, because it is metabolically very expensive for the parent to raise another human being. And for the offspring, it leaves them in a very vulnerable position, being dependent on somebody else for their survival for so long. So there's got to be a big payoff for us having this design, and one of the compelling arguments is that this extended period of immaturity gives us this extended period of brain plasticity that allows us to do all of the massive amount of learning that we have to do as humans. So parents in many ways are providing a scaffolding on a building. They're providing a scaffolding on our central nervous system to give us the luxury of childhood. So Again, we turn to the rodent research, which has done a very nice job of explaining this intimate relationship between the role of the caregiver and brain development. Now, when talking about rats, the caregiver is always the mother. So I'm summarizing here the work of my collaborator, Regina Sullivan, who has shown that in rat pups, the functioning of the amygdala right after birth is very different than in adulthood. So in newborn rats, the amygdala doesn't activate. It doesn't activate to threat. It doesn't activate to predator odor. It doesn't activate to shock. And that's very different than what it does in adulthood, where of course it would activate to all of those things. But there's this period, this intermediate period, when the functioning of the amygdala completely depends on whether the mother is in the nest or not. So if the mother is in the nest, then she leads to this neurohormonal cascade that ends up quieting the amygdala. So if the mother is in the nest, then the amygdala of this animal acts like a newborn. And if that mother is out of the nest, the amygdala of that same animal now acts like an adult. So the mother is turning on and off the functioning of the amygdala. And that plays out behaviorally in a very interesting way. So the workhorse of fear learning, the fear learning literature, is Pavlovian fear conditioning. So in other words, if you and I were presented with a peppermint odor and a foot shock, we would quickly learn that we don't like that peppermint odor. And that learning is dependent on the amygdala. And if you do that with this rat pup here, they will do the same thing. So if you put the peppermint odor at one arm of a Y maze and you put a control odor on the other arm, this rat pup will avoid that peppermint odor if its mother was out of the nest. But if this conditioning happens in the presence of the mother, she keeps the amygdala quiet. And so now what starts to happen is this rat pup not only does not avoid that peppermint odor, but it approaches that peppermint odor. And that's what's shown here in the black bars. So if that's confusing to you, then you've got it right. So in other words, this rat pup does not like a foot shock, but if it learns to pair a foot shock with a peppermint odor in its mother's presence, it will now start to approach that peppermint odor. And the explanation is that for you and me, survival is about fighting or fleeing. But if you're a young animal, neither of those strategies is very helpful for you because you can't do either well. And instead, for the young altricial animal, attachment is our survival strategy. That means that we have to, as young animals, we have to learn to attach to our caregivers no matter what. Whether we receive good care or whether we don't receive good care, we're still going to attach to our parents. And so whether this peppermint odor were paired with a foot shock or something rewarding, it doesn't matter. The young pup would still approach it if it was learned in its mother's presence. And that finding is very helpful in explaining the seemingly confusing behavior of young children who may have experienced maltreatment by their parents and yet are still very strongly attached to the parent. It may not be a fully healthy attachment because of the maltreatment, but the attachment is very strong. So we were very interested to know whether in human development we would see evidence of this at the biological and behavioral level. And moreover, would we see evidence, given that human development is so stretched out compared to the rat, would we see evidence of this in middle childhood? So these are data from Megan Gunner's lab. She measured cortisol, which is one of our primary stress hormones. She measured cortisol as children prepared for the Trier social stress test. And if you don't know what that is, it's a very effective way to activate stress physiology because it's giving a public speech. And young children would prepare for giving this public speech sitting next to a stranger or their parent. If they sat next to a stranger, they showed a very healthy cortisol response. And if they sat next to their parent while they prepared, the parent blocked cortisol response. Adolescents did not show that same pattern. Adolescents would show a nice, healthy court response, whether they were sitting next to their parent or a stranger. So we collaborated with Regina Sullivan to ask whether that fear learning, that kind of paradoxical fear learning, would be observed in children as well. So we presented young children with a blue square, and the blue square was co-terminated with a very aversive noise. We didn't use shock with children. This was an aversive noise, which was like loud nails down a chalkboard, which is a terrible noise. And the purple triangle was never paired with that noise. And so this is just to show you that young children also do not like that noise. So that's a good confirmation check. So children learn these associations either sitting next to a friendly female experimenter or seated next to their parent. Now, their parent was not doing anything to them. They were filling out questionnaires and the child had headphones on, so they weren't interacting with each other, but the parent was physically present. Following this conditioning, the parent left, and then we put children into a human Y maze. This is a tent, and one arm of a door had the blue square, the CS+, and the other arm had the purple triangle. And the question is, which door would children choose to crawl through to retrieve a prize? And we showed them that the same bucket of toys was behind both doors. We just wanted them to pick a door to get their prize. We had the opportunity to scan children and adolescents while they were presented with parental cues. Here we used a picture of parents because pictures are a powerful cue for primates. And we contrasted amygdala response to when children were looking at pictures of somebody else's parent, an unfamiliar person. And we saw in childhood that the parental stimulus was dampening amygdala reactivity in childhood, which we interpreted to be parental buffering, perhaps similar to what was observed in the rat study. Notice that the adolescents aren't showing that buffering. They're not differentiating amygdala response based on parents versus strangers. And that's not to say that parents aren't important during adolescence. They definitely are. It just may be that at the level of the amygdala, the parent has started to lose some of their potency in its activity. And we saw in childhood that the presentation of the parental cue momentarily strengthened that negative correlation, that connectivity between amygdala and prefrontal cortex. So in other words, when children are without their parental cue, we see the more childlike, non-regulatory pattern. But when children are presented with a parental cue, at least phasically, momentarily, we see that more regulated pattern between amygdala and prefrontal cortex. And we think it's that routine day in and day out co-activation that parents are producing that helps give rise to our adult-like form that we use when we're independent from our parents. Moreover, the strength of this connectivity was moderated by attachment security with the parents. So children that were reporting more attachment security had more of an effect in this connectivity measure. So everything I've presented so far relies on the parent exhibiting regulated behaviors in the rat and the human. The parent themselves has to be calm. If parents exhibit a lot of anxiety or emotion dysregulation, then it turns out that parents are equally really good at ramping up amygdala and fear systems, better than anybody else is. And so to model that, we now had parents undergo the fear conditioning. So this is me, and I'm learning that this pink circle is paired with that aversive noise. So I am quickly learning to not like that pink circle. So we would videotape me getting conditioned and then show that video to my daughter. She would watch me get conditioned and she would watch somebody else's parent get conditioned. And then in the scanner, we would present her with the stimuli that I got conditioned to and the stimuli that somebody else's parent got conditioned to. And what we see is that children learn better from their parents to dislike. Down means better learning. They learn to dislike the stimulus that their parent got fear conditioned to over and above what a stranger conditioned to. And the stimulus that I got conditioned to, the pink circle, was more effective in activating her amygdala than the stimulus that she watched somebody else get conditioned to. So taken together, these data are informing this working model whereby during childhood, perhaps earlier, we don't have those data, during childhood, parents are really effective in amplifying and attenuating amygdala reactivity and associated behaviors. And I have the up and down arrows there because sometimes people ask me, does this mean that I should be around my child all the time, buffering them? And the answer is definitely no. It's actually important for us during development to learn about things that aren't necessarily pleasant and learn that we can overcome them. And parents are very helpful in helping us come back down as well. So we think that the up and down nature of this reactivity and coming down is critical for helping to tone the system so that the nature of the functioning of our amygdala and prefrontal cortex in maturity is a reflection of the toning that happened during this putative sensitive period. And we have some ideas about the neurohormonal cascades that get instantiated when the parent is unavailable versus when the parent becomes available again. So in other words, parents seem to be a privileged information source for emotion regulation neurobiology. Now, I have a few slides remaining in my talk where I want to just turn to development following a very unusual caregiving situation, which is early institutional care. So institutional caregiving, which we commonly call orphanages, is a very stressful caregiving situation for the human infant, because even in the best of intentions, best case scenario, this is very different from growing up in a family situation, in large part because, again, even with the best of intentions, the caregivers are staff members. They're not parents. They're rotating shifts. They go home on the weekends. They're responsible for many, many babies at once, and it's a potent stressor. The children that we've been lucky enough to work with and follow over time have been adopted into the U.S., and I just want to briefly point out that the families that adopt internationally are a very special group of parents, because we infer at least that they must have a great desire to provide care, because it's not easy to adopt internationally. And so it's a striking difference in caregiving environments from institutional care to living in a family. So despite significant developmental risk at the point of adoption because of this stressor in infancy, children tend to show really significant rebound in several developmental domains, which is perhaps not surprising given what I've described about the families that children are moving into. Importantly, there's tremendous heterogeneity. So some children are really thriving, no matter what metric we use, and some children may be struggling in some domains. And if children are struggling, it's often in the domain of self-regulation or emotion regulation difficulty. So the data that I'll show you are from children that had largely been placed initially in institutional care at birth or by their 6-month birthday, and overwhelmingly adopted by their 2nd birthday. Now, if we consider this potent stressor, we can turn to the stress literature to generate some hypotheses. And the rodent literature has shown us several times that stress tends to lead to larger amygdala volumes, more reactive amygdalas, and that's in stark contrast to the neighboring hippocampus, which tends to show decreased complexity and smaller volumes. These are data from adults. If we look at development, I think the story is much more interesting. Several labs now have shown that following early stress, if we look during development, what's actually observed is what seems to be an acceleration of brain development. And when we first came across this literature, it was surprising in many ways because the prevailing theme in the stress literature is that stress leads to impairment in function. But instead, the neuroscience literature was suggesting that there might be, at least momentarily during development, a facilitation of function so that you get more adult-like phenotypes emerging. So the idea here is that when we see differences in brain and behavior following early stress, what we may actually be observing are developmental adaptations, changes that the brain experiences in order to meet one's immediate needs. So these are very adaptive things that we would want to happen if exposed to stress. But this view also allows us to consider both the benefits but also the potential costs associated with adaptation. So if we look behaviorally at outcomes, we can look at a number of different metrics, but our lab tends to focus on internalizing problems, which is a collective description of things like anxiety and depressive type symptoms. And following institutional care, we can see that there's a significant increase in these internalizing problems, and this effect size is considered a very large effect size, and this is with 373 participants. But the other thing I want to point out is there's tremendous heterogeneity. There's a lot of individual differences here. And so we're very interested in understanding why some children may get scores down here and others up here. What's leading to those differences? So what we saw was that following early institutional care, there was a greater tendency to rely on exploitation strategies. So children were cashing in at earlier points to make sure that the balloon didn't pop. Whereas the children in the typically raised comparison group would keep on pumping. They were more likely to lean on exploratory strategies. However, by the end of the task, there were no group differences in total earnings. So both groups got to the same endpoint, but they took different roads to get there. And in fact, it was one's trait anxiety that explained the strategy that children used. Now, context mattered. The more, in the generous balloon condition, the more exploitative, the more you cashed in, the fewer earnings that were made. And you can see that the post-institutionalized group in the dark dots were earning less. But in the condition where the balloon was harsher, it popped earlier, now the exploitative strategy paid off, and you can see that the group in the post-institutionalized group were now outperforming the typically raised children. So context when measuring really makes a difference. What we think is happening is that if this is age on the x-axis here, in the context of amygdala hyperactivity to this early adverse environment, it may be that the medial prefrontal cortex connections start to emerge earlier through an activity-based process. But if so, that may also bring along with it a reduction in this developmental plasticity. It may truncate the sensitive period. But there are benefits. There are immediate benefits. So although overall, following early institutional care, separation anxiety is significantly higher, those children in the post-institutionalized group who showed the adult-like adaptation had lower separation anxiety than the children in the who did not show that adaptation. So current anxiety seemed to benefit from this adaptation. Now this is my last two data slides here, but the next question was, well, there seems to be some immediate benefit, but is there another cost we should be paying attention to? And so we looked at whether this accelerated development, or what we think might be accelerated development, might place limits on parental buffering of the amygdala during childhood. So we repeated the parent-stranger experiment, and these are the data I showed you earlier, where children in the typical caregiving group seem to show this buffering of the amygdala. At the group level, we didn't see evidence of that parental buffering in childhood following early institutional care. But notice that these error bars are really large, which means there's a lot of individual differences in there. So we interrogated those individual differences in a longitudinal design, and we split children into whether they showed that buffering of the amygdala at time 1 or not. And we observed that within the post-institutionalized group, children that exhibited buffering of the amygdala at time 1 had steeper declines in anxiety than children that didn't show that buffering. So there seemed to be this longer-term benefit to maintaining the childlike state. And lastly, we wanted to know what differentiated these two groups, and the one variable that emerged most strongly for us was attachment security. So children that reported a more secure feeling in the parent-child relationship were those that were showing buffering at time 1. So I think these data are very important because they suggest that although we tend to think of plasticity as being exclusive to the early infant period, these suggest that plasticity might be really stretched out in the human and has important implications for intervention efforts in children who are beyond that early stage. And I'm happy to take any questions. So the question is, I think, correct me if I'm wrong, can I comment on caregiving situations where a child is going to daycare, for example? Yeah, so my understanding of the literature and the recommendations put out by the American Pediatrics Association is that from about 2 and on, that daycare has a lot of benefits, and before that, one-on-one care is optimal if possible. I get this question sometimes when I'm talking about institutional care settings and what's the difference with, daycare that children are going to. And my understanding is that with children going to daycare, that there is a rhythm and a routine of always coming back to the parent at the end of the day. And so it's that expectation that in part I think is like those up and down green arrows that I was putting in, that as long as, when my children were in daycare, the mantra was, mommy always comes back, right? It's like that's built in. And so as long as the routine is set up, then that can be a very positive experience for children. So the question is, you have a family that by many definitions is functioning very well, and then something happens and the parent is not able to be that buffer. So we haven't directly studied that. I should say, I don't have the answers to that. We have a study going on right now that's actually very interested in that. Because what I've described here is one example of adversity, but there are many other, unfortunately, types of adversities that children can experience. So first, what you said is probably correct, that their buffering capacity has changed because they're dealing with their own difficulties. What you often see, depending on the age of the child, depending on what order of siblings they are and so on, you see children develop parentified behaviors where they start taking care of the parent, or they start taking care of their siblings, feeding them breakfast, getting them off to school, and so on. That is a literature I know less about, but my understanding of that literature is it's an interesting comparison to these brain data that I presented, right, because there's an element of growing up fast, right, because you have to. Right. And by many metrics, those kids often look like they're doing really well because they're responsible and you can count on them. But in adulthood, the literature that I'm aware of suggests that those are the individuals who are also more prone to anxiety and depressive symptoms. Okay. So it is actually consistent with these data of growing up fast, but I think that in both cases, thinking about them as adaptations rather than a deficit model is probably the right way to go. So the question is, I've shown you normal structures. What happens when families have abnormal structures? So it's a very complicated question you're asking, so tell me if I'm going down the right road or not. So there are lots of different family structures, and I think within the range of normal, there's still a lot of different family structures, and I think the issue is a matter of stability. So even if there are multiple adults that are taking care of children, but there's a stability about it, then I'm riffing here, but my understanding based on anthropological findings is that the child still forms an attachment to the caregiver, but the caregiver is made up of multiple people. It's when there's lots of changes in the caregiving when children are going to have a harder time establishing a secure attachment. So the question is, what if there's maltreatment or abuse or parental mental illness or other psychopathology? And it's related to your question too, and the prediction would be that development would be different, and in part we're predicting that it would influence the pacing of development. So it would be more of a qualitative difference rather than a quantitative difference. So the question is, what do I mean by a typical family? So I don't mean a two-parent household. I just mean a family where there is a caregiver or caregivers who are stable and routinely present, and the child develops a sense of safety, security, and predictability in that home. The question is there a difference between single caregiving and multiple? In terms of the types of things that we're talking about here, no, but I think what you're asking could be answered in the following way. If a single caregiving household is characterized by excessive stress to that single caregiver, that's going to add difficulty to the family. But that's because of the stress, not so much because of the single caregiver.